class, and welcome to your first video in our series about three-dimensional vectors. We're going to be covering the basics of three-dimensional vectors in this series. So first, we have to talk about the three-dimensional plane in general and three-dimensional points. So this is your two-dimensional plane. You're very used to working with this one. But here is your three-dimensional plane. So if you notice, you have an X and you have a Y, just like in your 2D. But then you have your vertical component as a Z. So your points go X, then Y, then Z. Three-dimensional planes are kind of hard to draw just because there's a lot of intersecting lines and it's hard to really draw three-dimensional things by hand well to begin with. In a two-dimensional plane, we have quadrants. Well, since we're no longer divided into four, we have what's called octants. A lot of times we deal with the first octant, which is like this positive X, positive Y, and positive Z. So kind of this front corner. A lot of times it's easy to think of it like the floor and the walls. So like the floor is your X, Y, and then your walls represent Y, Z, and X, Z, depending on which direction you're rotating. A lot of times we will use like just three-dimensional software to graph three-dimensional points because it looks a lot nicer, and then we can rotate it. But I might occasionally ask you to identify three-dimensional points or three-dimensional vectors just by looking at a picture. So you just have to be careful. So plot the point -3, 3, -1 in the coordinate system. So first, just take each component individually. -3 on the X. So here's your X. They're usually labeled because, again, a lot of times we rotate them. So if you want -X, you want to travel back here, -3. So that's not going to work. It's not A. Which means it's also not going to be D because it's not -3. So if we look here, we're going back 1, 2, 3. And this one is also going back 1, 2, 3. So then I find it's next easiest to think about your Y. So you're going on the positive Y. Both of these are going on the positive Y. You can kind of tell by their dotted lines. Positive Y, 3 spots. And then you're going -1, which means you're going down 1. This one is very clearly going up 1. And this one is going down. It almost doesn't look like it's going down because, again, we're trying to draw something three-dimensional. But that is your three-dimensional point. Just like with two-dimensional points, we can find distance and midpoint, and the formulas are very similar. If you recall, I told you really not to remember a formula for distance and midpoint, but to remember a process. And the same holds true here. This is your formal formula. I show it to you so you can see it, so you're exposed to it. And this is your formal formula. For distance, it's a big giant square root, and then you're subtracting your x's, your y's, and your z's, and then squaring that value. So again, they should always be positive. But remember, this is just kind of a application of the Pythagorean theorem. So you're figuring out how far apart your x's, y's, and z's are, squaring those, adding them up, and then square rooting them. Remember, midpoint is just average. So you're averaging your x's, averaging your y's, and averaging your z's. You're dividing by 2 because there's only 2 x's, 2 y's, and 2 z's in every single situation. So let's try it. Use these 2 points to find the distance. So first, again, I don't like the formula. How far apart are your x's? Your x's are starting at 7 and going to -2. So you're going down 9. Or they're 9 apart. Your y's are 4 and 0, so they're 4 apart. That was pretty easy. And then you're going from, on z's, you're going from -2 to +6, so that's going 8. Up or down doesn't matter because we're going to end up squaring them. And again, it's Pythagorean theorem. So 9 squared plus 4 squared plus 8 squared. And then this is a great time to bust out your calculator. As always, we should always reduce our radicals if we come across them, unless the directions in our problem tell us otherwise. So 9 squared plus 4 squared plus 8 squared, that's 161. So we can just leave it at that. Square root of 161. If we wanted, we could put in our calculator. I don't think 161 reduces very well. To find the midpoint, we just average. So when you average, you add. So 7 plus negative 2, and then we divide by 2. 7 plus negative 2 is 5 over 2. And then for the y's, we do 4 and 0. So 4 plus 0 divided by 2, which is just 2 over 2, which is 1. Oh, sorry. 4 over 2, which is 2. And then the last one, negative 2 and positive 6, which is 4 divided by 2, which is also 2. So here's our midpoint. Again, the process is very similar to what it was in 2D, except now you have a third dimension to think about. Here's a thought question for us, and this will be our last question of our video. If M is this point, M is the midpoint of the segment with the endpoints A and B, find B. So here we know, sometimes it helps to see, we have A and B, and yes, we're in three-dimensional space, but we're just trying to get a visual, and M is in the middle. So if A is here, and M is here, we want to find B. So what would be the point on the other end? There's a couple different ways you can approach this. I just like to think of how we're traveling. So if I start at negative 3 on the x and I go to 4, that means I'm going up 7, which means if I'm going to go the same distance again, I have to go 7 more than 4, so that 4 stays in the middle. 7 plus 4 is 11. Then do it again. For my y's, I start at 4 and go to 6. That's up 2, which means if 6 is going to be in the middle, I have to go up 2 again. 2 more than 6 is 8. And then finally, if I start at negative 6 and I go to 0, that means I'm going up 6, which means to get to B, I have to go up 6 again. So that means this would be 6. And that would be my point B. Feel free to rewind the video, go back and look over it, and then start on your assignment.